question 1 here in the tasks was very straightforward. Complete the following truth table for the OR logic gate. Now, you've got to remember here that in the OR logic gate, remember your rule. If either input is true or if both inputs are true, then you get an output of true. So here we've got either, these are your inputs A and B, there's a 1, so it doesn't matter what the other one is, as long as you have one of them as a 1 or both of them, you're going to get a 1 here, a 1 here, a 1 here, and you're going to get a 0 up here, then you do the final one by itself. So there's the answer for number 1. That's it there, that little truth table, and that was pretty much straightforward. Tick it off. Question 2. Question 2 involved, now you needed to be really careful here because it involved an AND gate and a NOT gate in disguise, which turns it into a NAND gate. Right, so this becomes a NAND gate now when you've got this little circle out in front. So that's a combination of an AND gate and a NOT gate. And then we'll talk about this little bit in a moment here. So, what you've got in question 2 there, I've got the diagram down here anyway in front of us. So going from left to right, I drew it out. I kind of marked in a few places here. I put in a Q there. I put in an R and S for myself, and I put in a P. Again, they're only labels. You can put in whatever you want, but I kind of told you about QPR and stuff like that being your outputs. So these are kind of considered inputs, but I did Q and P here, and P is, we'll see in a minute that P is actually in between the NOT and that. We'll see in a second. So, A and B here, 2 inputs. So you're going to have your 0, 0, 0, 1, 1, 0, 1, 1. So your 0, 1, 2, 3 in binary. Then, and this is the first bit here, A and B. So this is not the little circle here turning it into a NAND gate. This is just A and B. And the rule for A and B is, if both inputs are true, then your output is true. You remember the rule, you put in the 1, and then by process of deduction, the rest of them are going to be 0. Okay, so that's that bit there. Now that's kind of in between the and this little circle. That's kind of in there, let's say. So then to get as far as Q, which is just past that little circle, you've got to go not A and B, which turns it into a not and, which is a NAND gate. So basically, whatever output you got here is going into the NOT gate, and it's reversing it. So you got a 0 going in, you get a 1 out. You get a 0 going in, you get a 1 out. You get a 0 going in, you get a 1 out. You get a 1 going in, you get a 0 out. We're now at Q here, which is this stage here. So we've got 1, 1, 1, and 0. Now this was quite different here. We hadn't seen one of these yesterday. But basically, whatever value you have splits up into 2. So if I have a 1 coming in here, R is going to be 1, and S is going to be 1, going into the AND gate. If I have a 0 coming in here, R is going to be 0, and S is going to be 0. So, this again starting off is an AND gate. So I worked out the AND gate first. I worked out just R and S. So, remember that if your input coming in here is 1, R will be 1, and S will be 1. And an AND gate says that if both inputs are true, your output will be true. So that's why I'm getting a 1 here, a 1 here, a 1 here, because both of them will be 1, and I'm getting a 0 here. So that's the same. But I'm only just in between here now. I've got to do the not and here, giving me reversing this to a 0, to a 0, to a 0, and then the 0, reverse that to get a 1, and that's your Y. So P really should be kind of in between there if you look at it. But that's your output. And what does that resemble? What type of gate? An AND gate. An AND gate. That represents an AND gate when your inputs A and B, and you get 0, 0, 0, 1. So that represents an AND gate. I don't know, we asked that to identify. I don't think we are. So that's number 2. Just take a